Okay, so there's a few rules we need to know. Okay, number one, log base A. Actually, before that, let's go over what we did last lesson. So if A to the power of X equals Y, so this is what we did yesterday. Okay, then the log base A of Y is equal to that power. Alright, so that's what we need to know so that we can do the laws from that. So, to remember that, we put everything up like so. To keep the bases on the same side, and you can drop them down vertically. And the Y's and the Y's and X's interchange on either side of the equal sign. Alright? Hopefully that's going to be a useful way to remember it. Like I said yesterday, I was one that always forgot this method, okay, and then I saw that, and that helped me to remember it much more easily. Okay, so that's the definition of a log. So the laws, number one, log base A of xy, so you're multiplying two numbers together, log base A of x plus log base A of y. If you are ever interested in the proof, let me know, alright, and I'll do something about that in the future, but we'll just get content covered for the time being. So, when you're multiplying two numbers, you simply add the individual components with the logs together. Number two, log base A of x over y.
Yeah, I was trying to do that stuff yesterday.
So,
I said I was trying to do that stuff yesterday, but I have no idea how to do it.
were you an exercise too early, were you?
You said to work through the 4.4 yesterday.
I'm covering 4.4. Yeah, that's just from that. Shouldn't need to use any of this yet. Shouldn't need to use any of that because that's just focused on that one, mainly. Anyways, I'll have a look in a moment. Alright, so if the multiplication results in an addition, a division will result in a subtraction. So log base A of x, take away log base A of y. Okay, these are all in your notes. Third one, log base A of x to the power of n. Okay, so when you have a power, all you need to do is bring that power out the front. N log base A of x. Number four, log base A of 1. So the log to any base, remember we can have any number represented as A. You can have 10, you can have 2, 4, 5, 50, a million, E, which is what we'll be looking at mainly when we get to it. Alright, any base to 1 is 0. Any base, logarithm of 1 is 0. Five. Log base A of A. Okay, so if you're taking the log of some number with the same base number, any suggestion on what that's going to equal? 1. Okay, so by definition, we will be able to see that. Alright, but we'll just focus on content for now. Number 6. Log base A of 1 over x. Okay, so if I rewrite it slightly, log base A of x to the negative 1 using my index laws, what will that then become?
Negative 1 log A.
Good. Okay, so the power is negative 1, bring down that power. Negative log base A of x. And number 7, e to to the power of the natural log of x. So remember, the natural log is log base e. Alright, on your calculator. So when you see the button ln next to log, it is the natural log, so it's the log with the base e. Okay? And this one is going to be x. So really, all you're doing here is you are cancelling that power. Right. Has anyone got their reference sheet handy? I can't remember if any of them are on there. Let's have a look.
I reckon shit. I bought a desk yesterday.
Hey?
Bought a desk yesterday.
You
Bought a desk.
bought a desk. That would be a good help for you.
Sell your drums to Ruben.
Okay, so a reminder in your assessments, all your assessments coming up to and including the HC, you will have a copy of that sheet. Okay, so you need to be familiar with it, and it's used as a memory aid, not as a reliance on it. Okay, are there any of this sort of stuff on that sheet?
It has change of base.
Change of base, yep, that's what we're looking at next lesson.
Oh, that's it.
But none of the other laws?
No.
Right, so you need to know these, okay? Right, so they are all in your notes. Alright, examples, let's apply them. Evaluate. Log base 4 of 8 plus log base 4 of 2. Okay, so there's a couple of ways we can look at this. We can use our log laws, which we're about to do, or thinking about this. The base is 4, the answer needs to be 8. 4 to what power equals 8? 4 squared is 16.
Oh, yeah.
Okay, so that's where we've got some problems, and we will cover that when we get further into the topic. Okay, so this one, 4 to what power equals 2? Half. Take the square root of 4, you get 2. So that one I could write as half, but this one I can't do so straightforward. Okay. However, if I make a couple of manipulation changes, I can then change and make the result to work. So, log base a of 8 plus log base a of 4. Okay, is going to equal log base a of the product of 8 and 2. Okay. So log base 4 of 8 times 2. The log base 4, 16. So 4, the base, to the power of what equals 16? 2. The log base 4 of 8 plus log base 4 of 2 is 2. Alright, and that's really applying this first understanding of the definition of a log. Okay, log base 5 of 15. Take away log base 5 of 3. Right, are the bases the same in the logarithm? So you can, looking back and using your rules here. Okay, so a subtraction is rule number 2, it becomes a division. So log base 5 of 15 over 3. 3 or 5? 3. So log base 5 of 5. Okay, so 5 to the power of what equals 5? 1. Okay, and that's the rule here. That. Okay, AA, 5, 5. So the answer is going to be 1. C. Find the value of log base 3 of 72, take away 3 log base 3 of 2. Right, as it stands at the moment, is there a problem? Be 3 at the front here. Okay, so what can I do with that 3? Put it up for the power of 2. Okay, so you're applying this rule here. So n log base a of x, it becomes the log base a of x to the power of n. So log base 3 of 72, take away log base 3 of 2 to the power of 3. Okay, so you're really bringing that back up here for the power. Alright, so subtraction with the same base is really like your index law. Okay, so when you're multiplying with the same base, you add the powers. When you divide by the same base, you do a difference of the powers. So it's really your index laws again, because logarithms are the opposite of exponentials, exponents. So log base 3 of 72 divided by 2 to the power of 3. 2 to the power of 3 is 8. 72 divided by 8. So 8 times 9 is 72. So the base 3, let's do that one, just make sure everyone understands. So log base 3 of 9, if that equals some variable x, okay, then a to the power of x is equal to y. So the bases are dropped and the other two variables are interchanged. Okay, so you want to look at it that way. That becomes 3 to the power of x equals 9 once you replace those variables. Okay, that's what I've been saying, just not without the working. The 3 to the power of what equals 9? 2. So, in other words, 3 to the power of x equals 3 squared. So the bases are the same, the index must be the same as well. Any question? Right. Log base 2 of a quarter plus log base 4 of a half. So the formulas only work if we've got the same base, so we don't at this stage. Okay, so we make a couple of changes here. Right, we can look at it this way. 2 to the power of what equals a quarter? -2, okay? Because it's really 2 to the power of -2, isn't it? Okay, so log base 2 of a quarter is -2. So you can just write it down like this.
Solve each one
So, yeah,
by itself.
that's one way you can do it. It's not the only way. Okay, I'm just trying to show you different perspectives. So -2. So 4 to the power of what is a half? -1/2. So you take the square root of 4, which is 2, and you want that on the bottom, so you have to take it to the negative. Okay, does everyone follow what I've done? Yep. So what's -2 plus -1/2? -2.5, -2.5, -5/2, whatever. Alright, another style question that I like asking you, and I'm pretty sure there's some in HSC, past HSC exam. So, if log base A of 5 is 0.827, so they'll tell you what they are when you don't know what the bases are, and log base a of 2 is 0.356. You need to find the value of the following. Log base a of 1.25. Alright, convert that decimal to a fraction. What is 1.25 as a fraction? 1 1/4. Let's now convert that to an improper fraction. 5/4. So 1 1/4. So multiply the mixed number by the denominator and then add the numerator. Okay? Times, add. So 1 times 4 is 4, 4 plus 1 which is 5, and the denominator stays the same. Okay, so going back to my index laws, so I'm dividing with a log, so I'm going to do a subtraction. So log base a of 5, which I've already got, so I can use that value as 0.827. Take away log base a of 4. However, I don't have log base a of 4, so I still need to do something. What can I do? Sorry? Or times 2, you're on the right track, just reword it.
Log a times 2.
Sorry?
Log a times 2.
Log a times 2.
No, log a to the 2 times 2. Equals that.
Oh, yeah, okay, yep. But can we go back one step, make sure everyone understands? Alright, so that really becomes log base a of 5 minus log base a of 2 squared. And then you do what he's saying, bring that 2 down. Okay, so I just want to go back one step. Alright, so log base a of 5 is 0.827. Take away 2 lots of, so you bring that power down, log base a of 2, 0.356. Okay, so at that point you go to calculator and punch it all in. There's no approximation. Right, so you write it in exact form how you get in the calculator, unless it tells you to do an approximation. Right, double I. Log base a of 10. So, what can I do with log base a of 10 so that I can use a combination of either or both of what I've been told? 5 times 2, isn't it? 10 is 5 times 2. So log base a of 5 times 2 gives 10. And then it's your log laws. Okay, so when you're multiplying, it's an addition of the individual component. Log base a of 5 plus log base a of 2. You're going to have something slightly bigger than 1. Okay, so I'll trust that you can put that in the calculator and give me a correct answer from there. Log base a of 0.8. Right, so decimal, I don't want to work with decimals, I'd much rather work with fraction. So what's 0.8 is a fraction? 4/5. Okay, and I've just about got everything I need. It's very similar to what we did here, just a reciprocal. Okay, so log base a of 4, take away log base a of 5. The order is important. Okay, numerator to take away the denominator. It's going to be 2 log A of 2, take away log A of 5. So this was 2 squared. And then you bring the 2 down. That's why it's over here. So 2 times 0.356, take away 0.827. Okay, so a bit of manipulation, and they can get a bit more tricky and not so obvious. Alright, so that's just a starter. Alright, last one. Solve log base 10 of x squared plus log base 10 of 8x, and that equals 3. Right, suggestions on the first step. Good. Okay, so we're adding to the same base. So log base 10 of x squared times 8x is equal to 3. So log 10 of 8x cubed is equal to 3. Alright, and then going back to your definition of a log to help you with the next step. So, a to the power of x is equal to y. So the bases drop down vertically, and the other two variables are interchanged. So 10 is the base to the power of 3 is equal to this part on the right hand side, 8x to the power of 3. Okay, so now you have a equation to solve. Divide both sides by 8. So we've got 10 to the power of 3, which is 1,000. 1,000 divided by 8, half of a quarter. As in 8x equals 10. Is that what you're saying?
No, get rid of the cube, so it's going to be 10 equals 12.
Yes, that's another way you can do it, yes. Okay, if you want to do it that way, go for it. So she's suggesting write this as 2 to the power of 3 and then remove the cubes after that. That's one way you can do it. So what's half of 1,000?
500.
Half of 500?
250.
Half 250?
47.
Okay, so you've just divided by 8. Or found 1/8 of by dividing by 2 3 times. What number cubed gives 125? 5. We're at 4.5 now. Any question?
What did you manage to